All right, so here we are back with geometry and looking at circles and particularly the difference between arcs and sectors and connecting it back to what we learned before about areas and circumference of a circle. Anyhow, first, let's just get straight to this. I have a circle with a radius 5 centimeters and has an arc that subtends an angle of 60 degrees. So what does that mean? Well, here's my circle. A radius of 5 centimeters, again, if it's the radius, doesn't matter where I draw it, it's the same distance anywhere around. So I'll draw that like right here. And I'll label that as 5 centimeters. And I could have drawn that anywhere. If we say it subtends an arc of 60 degrees, then we imagine 60 degrees, from one side to another. So let's say roughly about there, that's roughly 60 degrees. And so that little slice I've shown, this here we call a sector, the two-dimensional shape. The distance from the outside we call an arc. And so in this case, that angle there was 60 degrees, and since this is a circle, each of these sides must be the same length. They're both 5 centimeters. And so there, now what you see is what's being described here. A circle with a radius of 5 centimeters, and the arc is this part here that I'll leave highlighted in yellow. All right, and so let's determine that arc length. Well, one of the key ideas is that part of highlighted is really just a piece of the circumference, and the circumference of any circle is pi times the diameter, or 2 pi r. So 2 pi r is the circumference of any circle. I have only a piece of that circle, and that piece is based on this angle of 60 degrees. So if I think about how does 60 degrees compare to a full circle, well, 60 out of 360 is 1/6. So really what I'm looking at is 1/6 of the circumference. And so I can find the length of that arc if I find the circumference of the whole circle and divide by 6, or find a sixth of it. Or a little more formally, I can say the length is the same as my angle divided by 360 times the circumference of a circle. In this case, that angle again is 60 degrees out of 360. And the circumference is 2 times pi times the radius. Now it's a matter of just simplifying this. There's my angle, and I'm trying to find the length. And so at this point, it's a matter of just simplification. I get 1/6 times 10 pi, or simplifies to 5 pi over 3. And I do ask for an exact answer here, so I'll say 5 pi over 3 centimeters. Oh, not centimeters squared, centimeters. All right, so I wrote, for a moment there, I accidentally wrote centimeters squared. That would make sense if I was looking at the area, which is the next part of the question. I'm looking at this area, then I'll highlight all in blue. The area of this region we call a sector. And same idea. We can find the area of that sector by thinking about how does that slice there compared to the area of a full circle. Well, the area of a full circle is pi r squared. And so again, the area of that slice, that sector I should say, is 1/6 of the area of the full circle. And it's 1/6 because it's the angle divided by 360. That tells us the proportion of the sector. And so this is going to be my area. And so very similar to before, I have 60 degrees divided by 360 times pi. The radius is still 5 squared. And the matter of just cleaning this up, if I wanted to make it exact, I would get 1/6 times 25 pi, or 25 pi over 6. That's my exact answer. I do ask for it to be expressed to 3 significant figures. So decimalize this, and you get approximately 13.1 square centimeters. And as you've seen before, anytime we're dealing with pi, you cannot express it exactly in decimal form because pi is an irrational number that cannot be expressed exactly as a decimal. All right, so here now, I don't have a visual, but I can easily create one. So I have a circle with a radius of 10 and an arc length of 12 centimeters, and it's subtended by an central angle of theta. So what is that angle? I want my answer to 3 significant figures. While I don't have to create a visual, I think it's quite helpful. Here's my best attempt at a circle. That's actually not too bad. And we know the radius is 10 centimeters. So let me draw that. Take 2. Take 3, perhaps. There we go. And that's 10 centimeters. And we don't know the angle, but we know whatever the angle is, it creates an arc length of 12, a little bit longer than 10. So I'm going to, visualize the distance from here to here being a little bit longer than that 10 centimeters. So I don't know, something like, doesn't really matter. Something like this, let's say. And so these are both the same. So I don't know the angle, but I know the arc. And so I'll label that. All right, so I can now figure this out using essentially that same proportion as before. Now what I have here, length equals theta over 360 times 2 pi r, is really just a variation of what I have right here. This is the most important part, that the proportion of an angle to a full rotation is always equivalent to the arc length to the full circumference. It's kind of what I mentioned before. And so in this case, I'm going to use that proportion here. So I don't know the angle, but I know that divided by 360 degrees should be proportional to the arc length, which I know, compared to the entire circumference of the circle, which is 2 pi times r, or in this case, times 10. And so if I solve for theta here, I pretty quickly get 12 times 360 degrees divided by 20 pi. And I don't really have to simplify this because I do ask for it to be written to 3 significant figures, but if you do simplify it, it comes to 216 over pi, which is approximately 68.8 degrees to 3 significant figures. All right, so last question, trickiest question. I want to find the area of the region bounded by the orange arc and the chord. Now a chord is a line that goes through a circle but not through the center, so that's a chord right there. And so I want to find the area between the chord and the arc, which means I'm looking for this angle, this region here, the area of that region there. All right, so how do I figure that out? Well, one thing I can do is realize, okay, let's ignore the chord for a bit and let's find the area of this whole sector, because that's what we've been doing for part of this lesson. And it's relatively quick. So that whole sector there, so the area of that sector, again, is the same as the angle that we're subtending, in this case 100 degrees divided by 360 times the full area of the circle, which is pi times the radius, in this case 2.85 squared. And I'll just right away bring this to a whole bunch of significant figures. You get approximately 7.08822. And I don't actually have any units here, but that's the area of that entire sector, a little more than 7 square units. All right, I want the area of just that last little region before, so how can I figure that little region? Well, I can now take that answer I just have and subtract the area of this triangle I'm coloring in. So how do I find the area of this triangle? Well, we've seen this lots actually in our geometry so far, that I can find the area of any triangle if I know 2 sides, which I do because these are the same, and the angle between them, which I know. And so I can find the area of that triangle really quickly using this formula here, which came up in an earlier lesson. So the area of the triangle, the general form we show it is 1/2 AB sine of C, or A and B are any 2 sides of the triangle, and C is the angle between them. And so in this case, it's 1/2 A and B are the same, 2.85 squared times the sine of 100. Really easy to forget that formula, but so crucial, because you don't really have to find the height and the base and all that other good stuff. At this point, I should quickly be able to get this on my calculator and get just barely shy of 4 whole units. I got 3.99955. I'm deliberately keeping many decimal places here so that when I eventually write my answer to 3 significant figures, I know it's accurate. And so keep in mind now the area I'm trying to find is the difference between the sector and the triangle. So the area that I want is going to be the 7.08822. That's a weird looking 8. Minus 3.99955, which again, deliberately gave myself lots of of accuracy here, and you get approximately to 3 significant figures, 3.09 square units, whatever those units are, square centimeters, inches, light years, whatever makes you happy. There you go.